Good evening, everybody, and thank you all for coming on a nice Thursday that I'm sure you could be doing better things with your time, but we're all here because everybody's interested in maths education in some way or another. And I will admit that I was petrified about trying to write this because I'm not sure who's in the audience. And if I could get a little show of hands, do we have maths teachers here? A small number, that's okay. Well, this probably makes things better. And then, can you shout out the rest of you interested in maths, just working in maths in industry? Parents. Academia? Pardon? E-learning? Okay, very nice. Parents. Okay, very good. That's a good voice to have as well. So maybe we'll get more info on the audience as we're going through. And I'd really like this to be more a discussion than in any way a sort of a lecture. So as we're going along, I'd love you to contribute. So if you have, you can put up your hand at any stage, and if we can get to the mic, we will. But it's quite a small room, so hopefully we'll be able to communicate with one another like that. So what is the future of mathematics education? And that is a question mark. We are not here to say that we have any answers, and I think it's a very broad topic, and it's something that there is a lot of avenues to. So let's discuss that. Let's discuss the question. And I wanted to put this in there, and now I'm not quite so sure was it a good idea. I decided to say from Pythagoras to Polya, because Pythagoras is, well, as far as we know, one of the earliest maths teachers. He was one of the earliest people to take a group and to try and teach them or to try and discover mathematics. And Polya, George Polya, if you're aware of him, he was a Hungarian mathematician and really kind of brought forward the idea of problem solving and making maths exciting and a little bit more creative for students. So we're going to track that a little bit. I'd really like to invite Dr. Terry Maguire or to thank Dr. Terry Maguire and Rachel Thomas for joining me today. Dr. Terry Maguire is the head of lifelong learning at ITT Dublin, and she is the creator of Have You Got Maths Eyes? And I would recommend anybody to go to the website haveyougotmathseyes.com to look at the work that she has there. And it's brilliant public engagement with maths, to look at maths not just as homework. And Terry asked a question, she said today, because she was organising a conference, and she asked the parents that were in the conference, how many times do you talk to your children about maths that isn't homework? And when you think about it, actually, do we do that at all? So Have You Got Maths Eyes is something that's very relevant, and I think something that everyone can take home with them. And Rachel Thomas flew in from London to join us today. Thank you very much, Rachel. Rachel's involved in the Millenium Mathematics Project, and she's the editor of Plus magazine that looks at maths teaching, and that's an e-magazine that everyone can access. And Rachel also worked with Enrich, which is a UK-based program for maths teachers, which has fantastic resources on it as well. So I'm delighted to have them both here because they've both a wealth of experience in maths education and two very different angles on it as well. So thank you very much for joining me this evening. I wanted to have a brief look then at looking at teaching mathematics. So maybe, what can you tell me about that picture? Pardon? Yuck, okay. What else about the students, perhaps? They're all solitary. They're all working on their own. Where's the teacher in that classroom? He's at the top of the classroom. So what do you think those students are doing in that exercise, maybe? They're probably copying something down. Okay, so that's an old version of maths. And thankfully, when we move on, we see that we've really changed a lot in the term of the modern mathematics classroom. Because as you can see, a lot has changed here. What do we have? We've got colour and we've got phones. And little else has actually changed. And I hate to say, but unfortunately, this is actually the norm in a lot of maths classrooms still. Not a lot that I've seen because I work with really great teachers, but I just know anecdotally that this is still how maths is being taught in our classrooms. So despite having all of the technology at our fingertips, and despite knowing so much about theories of learning and philosophies of learning, little is actually changing in our classroom, and that's what I think we need to discuss a little bit more today. Trends in education. You may not know this guy, but I'm sure you know what he did. This is Skinner and his dog. And please correct me if I make any mistakes in this, because psychology is not my forte, and theories of learning does fall into that at some stage. So his dog, his salivating dog, he decided that he could teach it to do anything. So when the dog heard a bell ring, he trained it to salivate because he used to give it food after the bell rang. And after that, he did it for long periods of time. So anytime this dog heard a bell ring, it salivated, and that was learning. But that's actually how psychologists thought everybody learned at that stage, not just dogs. That you program people how to do things according, that's the Jenga tower falling outside, that's risk. But that's how, we had this idea of learning that you go through stages of learning, and as you grow up, you follow from one stage to another. And so until 7, you can add maths, and then maybe if you're 10, you can multiply, and after that, maybe you can do something a bit more difficult. And that's how psychologists thought that learning was. Then we moved on to behaviorism. So behaviorism, this kind of steps that follow it like that is, I follow the instructions, I take the test, and I get the reward. But am I learning anything? Because with that, I'm just learning a procedure. With behaviorism, you can teach me how to differentiate, and I will do those 5 steps, and I will get it right every time. But when I'm asked then, when I get to college, to use it in some sort of context, I haven't a clue what even I'm supposed to be doing, because I haven't understood what's behind it at all. So I know the procedure, I know the instructions, and I got the reward because I did really well on my test on it, but I actually don't know when or how I should use it. And unfortunately, behaviorism is the way that we test our students in general, in terms of summative assessments like state exams, etc. And there is a merit to them, like we do need them as well, but I think there's far more to the philosophy of learning than just behaviorism like that. Then we moved on to cognitivism and looking at, well, how do we learn in terms of the brain? What's happening in the neurology of it? I'm not a big fan of it, but this is how the trend has led on. And now constructivism is the new trend, that students construct learning with themselves. But the downfall of constructivism is we're only looking at students as individuals. And they come across something that they don't know, and they meet a frustration with it, and that's how they learn from it. And it is a good way of looking at things, but I think actually we can do a little bit better with it. So even though constructivism has a lot of good merits, and you could read more about them, I have those references there, and I think we'll share this slide later on, but I think we can do more than constructivism. So what I'm looking at now, and what the new trend is in education internationally, is looking at socioculturalism as a theory of learning. So in socioculturalism, you're looking at the student as an individual, yes, learning something, but they're learning through their social interactions. They're learning through their discussion with their classmates. They're learning through the teacher asking them specific questions. And what's important with this is that the teacher doesn't have a set plan to go with. The teacher is listening to the students, and as their students are meeting problems, the teacher is changing their questioning to try and facilitate and to kind of scaffold how the students are learning. And then the students are having to explain to each other. And I think we'd all agree, I hope, that that's one of the best ways of learning, is having to tell someone else what it is that you're doing, because that really shows that you explain it. And you find out what you don't know then when you have to actually ask someone else. So in comparison to the pictures that I showed at the start, what's the difference now with this little photograph? We've got interaction. How are the students laid out? They're in groups. And where are they looking? They're looking at each other. Where's the teacher? She's in the middle somewhere. It's not dictatorial or didactic. She's not at the top of it. The students are talking to each other. They're looking at their own work, and they're settled in groups. And this is something that a lot of teachers are very afraid of. If you've learned in isolation, you've been teaching your students on an individual basis in rows like that for 20 years, it's very difficult to go to something like this, because this classroom is messy, this classroom is noisy, and you are giving over control because you're letting your students talk and you're letting them think. But what research finds is that this is actually the best way to learn, because they're not just learning procedures, they're learning why they're doing something, they're learning how they're doing something. And then when they're asked a problem in context or in real life, or when they move out and they meet maths problems, they're actually better able to cope with it because they've been doing it by themselves. So it's just examples like this where the teacher's not telling anybody what to do, but she's asking them, what did you do here? Okay, well, why did you do that? And the students will go, well, actually, I don't know why. And then if the students have to present the work to one another, they will be their own best critics saying, well, why did you do it that way and not this way? And when you see it work, you see how engaged the students are. And if they're engaged, they are going to be learning. So, yes, please do, Terry.
Very common there. If you look at the guy with the blue t-shirt, he's He's enjoying himself in the maths classroom.
That's a huge. That's
very important.
A huge outcome, yeah. And Joe Bowler did a study recently as well on 2 different schools. And one school was amazing and they got great results and the students were so quiet and calm and they all did their work really well. The other school was a little bit crazy. They only did maths through project work, a little bit bananas, kind of all over the place, not very enjoyable for the teacher because they had no control. But when she interviewed both sets of students, the good students hated maths. They hated that. They were so bored. They didn't like doing it. They only did it because they have to. And these students thought it was a really interesting subject, really creative. They didn't like it all the time, but they generally enjoyed it. And some more of those were going forward to study maths. So that's such an important point, that they're engaged and they're happy when they're doing these maths as well. So this is Pythagoras. And I was chatting with Terry and Rachel, and we were wondering, back in the Dark Ages, I don't know what century, I think it's the 6th century, when Pythagoras was teaching, how would he have taught? So he didn't have the classroom, he didn't have the blackboard. He would have taught his students through dialogue, sitting together in groups, chatting about the mathematics. And, Pythagoras has had his cult and, may have died for finding the irrational number of root 2, but he would have, but he taught his students, I imagine, in a dialogic term, in the sociocultural term that I spoke about there. Somehow we moved to this image that the teacher is the fountain of all knowledge and the students will sit in their classroom static and the teacher will pour the knowledge into the students' brains if they are quiet and good and copy everything that the teacher does. And that is the behaviourist model of maths, rather than learning it for themselves. And I was chatting to a taxi driver this morning in Cork, because I was down there for a conference as well, and he was saying that he loved maths. And he couldn't tell me what made this teacher good. But he said, I do remember being asked why I did something and how I did something. And I said, oh, so you talked in that class? He goes, oh yeah, we always talked in that class. And he has fond memories of maths. But he also told me that he remembers the stick, and he remembers being, hit as a 9 and 10-year-old and hated those teachers and hated that classroom. But he loved his maths teacher and he loved his history teacher because they asked questions and they wanted the students' opinions. And he got an honour in his honours maths and he got an honour in his history as well. But it was actually the dialogue that made him love that subject. And now we're moving, I hope, to the Polya way of thinking, which is based on problem solving. And his book that he wrote in the 60s, How to Solve It, is still a basis of a lot of international curricula now because it's all kind of problem solving based. So that's where I was getting the Pythagoras to Polya. And because I think it's come full circle. I think it has come from teaching in groups based on talking to each other. We went a little bit aside with behaviorism. Maybe we needed to go there for a while and learn about those aspects of psychology, etc. And now maybe hopefully go back to the ways of group learning. So how do we learn mathematics? Well, I believe that students actively construct their maths ways of knowing through their social and cultural interactions. So through talking to their teachers, through talking to their peers, through even having a dialogue if they're working on maths at home, with the internet, with the computer. Like it's still a communication, it's still a dialogue, even though even if it's through e-learning, it's still that dialogue. So I wanted to give you a quick problem that might be different to how you learned maths on your own. And I wanted to ask you, if you saw this pattern here, we've got our first block, our second, and our third. So this is just a little bit of a problem solved there. Well, what do you think is coming next? And I want you to chat to your neighbour about it. So whoever you're talking to, we're sitting beside, introduce yourself and just have a little chat and see, what do you think is coming next?
That's a nice noisy classroom.
That's a noisy classroom, yeah. And they're smiling.
And they're smiling.
Yeah.
Okay, folks, so we might bring it back down again. Now, before I go back to anything, I'd just like to say there that there were a lot of smiling faces while you got to do that. Why? Because people like talking. People like talking to each other. It's a good way of learning. And I imagine that most of you got the right answer, because even if you didn't think it, you were afraid that you might have the wrong answer, you were chatting to someone else, and that kind of gave you the confidence to be like, oh, I think I am actually right. So would anybody like to suggest what might the next pattern here be? Excellent. 4 by 4. And what would be after that then? 5 by 5. If I went to my 11th pattern, what would that be? 11 by 11. Okay, very good. Okay, what would my 100th pattern look like? 100 by 100. What would my Z pattern look like? Z by Z. So what's the pattern here? What's going on? We're squaring it. Wonderful. Now, you did it very well there. We would obviously do that much slower with the first and second year group. But that's an example of how you can learn maths through social interaction like that. And you all got it. You all got it really quickly. And I want to show you that this develops very quickly into something that I can look at in a more rigid, a rigorous term after we've spoken about it, because now you all have the confidence to talk about it. So now I'm looking at, well, these are my pictures, and I had 1 tile for the first one. I had 4 tiles for my second one. I used 9 for this one. How many did I use for the fourth? 16, and then for the fifth one, 25. Okay, so I see there's a pattern here. Do you think you could go on if I made this table really long? Okay, so this is what it might look like. So then with my little second years, I would go and ask them, and I'm skipping steps here because we don't have time, unfortunately, to go through it. What's the difference between the 1 and the 4 there? What am I doing to get from 1 to 4? I'm adding 3. What am I doing to get from 4 to 9? I'm adding 5. What am I doing to get from 9 to 16? And adding from 16 to 25. So I don't have do I have a pointer thing? Oh, okay. I don't have a pointer thing, but you can see what's happening with my first change there, as you can see it. 3, 5, 7, 9. There's a pattern there as well, isn't there? What's the pattern between the 3, 5, 7, 9? It's 2. They're going up in 2s. Is that weird? I don't know. It's just a pattern. But if we do loads of those, you will find out that that's actually a quadratic equation that you just got. You've already told me it's x squared. Now, I want to put this up because the fact that it's a 2 there doesn't mean that it's squared. But the fact that that's a common number going down means that it is squared, just in case anyone got confused by that. But I want to show you now that when this was done with second years, who had never looked at quadratic equations before, they had done linear patterns, and they were just given time and a blank sheet of paper. This is what they did. And look, it's amazing. They graphed it. They did their table. We didn't tell them to do a table or not. They just kind of came up with that by themselves. And they decided that they'd graph it. This next group did loads of work. There were 4 in a group. And they were all chatting to each other. They had kind of 15, 20 minutes to do their little problem. And you can see that they did 1 by 1, 2 by 2, 3 by 3. They figured out the pattern really easily. Up here, if you can see the horizontal there, they did their patterns, but just horizontally. And they made a little mistake. And they didn't figure that out till the end. And then they got their formula. It's x squared. We were doing it in slightly different terms. They got the right answer as well, though. And this group did it exactly the same, like that. So this isn't pie in the sky stuff. You enjoyed having that chat with your neighbour, but they enjoy working like that in a class group, but they're getting concrete mathematics done. They're learning from it. This teacher afterwards, 4 months later, said, do you know what? They're the strongest group that I've ever had doing quadratic equations, even now that we've moved on to factorizing. And he reckoned it was because we started introducing them like this in a way that was a game, but they had ownership of it then after that. So coming now to maths in Ireland, we once had a highly didactic approach with relatively little emphasis on problem solving. And that's from a number of papers that were published back in the 1990s and the early 2000s. Now we have a curriculum based on inquiry learning, and I'm afraid to say project maths because I'm sure people start throwing things at me. But project maths, it's meant that we have content changes in our curriculum, but only small ones. A little bit more probability, a little bit more statistics, some financial maths, which I thought was very useful because I was able to, for the first time in my life, calculate my pension and get a fright from it. But I think things like that should be on our syllabus. But what's most important about our changing curriculum is that we're changing how we're teaching and learning within the classroom. We want to move away from the early didactic individual, this is how you do it, just do it in the exam, repeat 7 of them, get an A1, come to college and not have a clue what you're on about. Or go out in real life and not be able to calculate 10% in a sale. Or know what your mortgage payments should be. Now it's, okay, well have a go, have a think about it. If you're having trouble, I'll come, I'm your teacher, I'm your guide. I will facilitate that learning because I'll ask you a question or I'll give you a nudge, I'll give you a little hint and I'll see that you can do this, that you have the confidence to work in this mathematics by yourself. So that's where we are in maths now. So I think the rest of the discussion, hopefully, we can have a chat about what does that mean for our future then? If our curriculum has changed, I mean, that doesn't mean anything unless teachers are changing. So what should the maths classroom look like now? What should the mathematics teacher look like, or be qualified for, or have to do? How should we assess the mathematics? Is the state exam the best answer for that? We'll have a chat there. What about the professional development for teachers? Is it enough to say that I do my degree for 4 years, I do my PDE for 1 year, soon to be 2 years, and then I'm let off and never assessed in my job again? No one observes me in my classroom again? No one ever says, do you know what, you're a brilliant teacher, or says, I think you could brush up on these few things. Is that appropriate? So what should be the professional development for teachers? And how should we engage the public in that? So we have time now to discuss that, and I think I'd like to open it up to Terry and ask, what does maths mean to you, first of all, and how might you address some of those problems?
Okay, maths means everything to me, but I suppose in a better way to say it, maths education means everything to me. That we can actually have students going into our classroom that actually have a learning experience that meets their particular needs. And it's interesting the way that you've set up this list, because I would have put engaging the public at the top end.
Yes.
Right? But that's just where I'm coming from. Because my background would be working with adults who are returning to education. So school mathematics has actually failed them once before. They haven't got successfully through the system that was on offer. So I would be saying we have hundreds of parents out there who don't feel that they're any good at mathematics. And they all have this view that mathematics is about school. Mm-hmm. And we're talking about the classroom, we're talking about the teacher, the assessment of mathematics, the professional development teachers. That's not right. That's giving them the notion that mathematics is only about school. It's not, right? People do mathematics every single day of their lives, right? But when they think about it as being mathematics in school. So they say everything that they can do, they say it's common sense. It's only what I can't do in my everyday life is actually mathematics. So we've got this new program coming in, and I think the Project Maths will actually have a big impact in terms of the view that our students coming out of school will have about the usefulness of mathematics. But change takes time. And we have huge numbers of people, like myself, that have gone through a very abstract, formulaic system with the teacher on the front, where we actually say we have this people at home, our Project Maths students are going home to perhaps a parent that's saying, it's all right, love, about maths. I wasn't any good at them myself, right? But how can we change that? And we can't change that perception until we actually persuade all of us and all of people like us, regardless of whether we were good at school maths or not, that we are good at mathematics.
Sorry, slightly different at that. My 8-year-old daughter comes home from school. She comes into a house where maths is a big part of my life and my job. And my wife has been a housewife for the last 8 years and worked in finance before that, so maths is in the house. But my daughter comes back from school going, I'm no good at maths. None of the girls are any good at maths. And we're continually challenging her, asking her, how much does this cost? Or asking her things that aren't her homework. Asking her, well, if there's 3 wheels there and it's unbalanced, what's going to make it balanced, and that sort of thing. So that's kind of the other side of it. And that's what we're fighting. And fighting is the wrong word, but that's what we're going through at home. How do I convince my 2 daughters that maths isn't difficult? It is something that you use every day, something that you have to use, and it shouldn't be a trauma.
Mm-hmm. But I think part of the issue is calling it maths. I mean, that's the big thing. I remember when I left university, so I did a maths degree at uni, and one of the things one of my lecturers said, okay, every time you ever have to, no matter what job you go on to, can you please write on any form that you ever fill in that asks what you do for a living, can you please write mathematician? Because her kind of thing was that basically you'll all go off and do jobs, but you will all take this training with you and you'll all be doing mathematics every day. So that's a slightly extreme thing, but the thing is we often don't call it maths, and that's probably what your daughters are finding. And, you know, we all do maths, you know, all day, every day. We do it as a form of common sense. Most people are incredibly numerate and have a incredibly good judge of risk, of have a good intuitive sense, because we're all geared to be able to deal with these kind of ideas, but we don't call it maths. So I think that's one of the things. It's essentially making, you know, as Terry's project says, you know, revealing the maths, showing everyone, so everyone can call it for what it is, and then it doesn't become, I mean, can you imagine, so there's some of the people I've worked with, kids I've worked with, and particularly with girls, there's a slight issue in that lots of girls who really enjoy maths, one of the things so many of them have said is that my mum tells me, you know, she was never any good at maths. And it's sort of, I think we all have to acknowledge that we are good at maths, but it's finding the confidence to say that and finding the confidence to own the maths that you do. So I sort of think it's an issue of, I do think it's a wider issue as well as obviously one in the classroom.
Well, I think it's a cultural issue, and I do apologise, Terry. I did focus this on the classroom, and I should have broadened it out, but I'm only really taking this as my experience as a teacher and now as a maths educator with PTE students and things like that. So that is my fault. I mean, I'm guilty of it as well, Derry.
Yeah, but I would ask this gentleman, what's happening in your daughter's classroom that she's walking away from school with this thing that she is no good at mathematics, and that she's confident enough to say that her friends are no good at mathematics? That's the bit I perhaps is where the classroom bit, what's actually happening, that she's walking out with that impression.
I don't know right now, and it's something that, you know, we want her to be positive, and we want her to have a good experience with maths. She shouldn't be afraid of it. There's no need to be afraid of it.
Anecdotally in that, a friend of mine, I was doing homework with their child, and the child was in high infants, I think, or something like that, and she was doing addition, so it was 4 plus 0, 4 plus 1, 4 plus 5. So obviously I got out pencils, and I was like, what's 4 plus 0, 4 plus 1? And she said, no, you have to do it like the teacher does it. And the teacher does it in rote learning, from a table. As in, I open this page, I learn off what this is, and I couldn't ask her in any order, only the way it was asked in the table. So I think, and I'm not blaming primary school teachers because they work wonderfully well, but I think there is scope to really look at how we approach teaching mathematics in primary school. I think that might be an option with it. Yeah, can we take a comment?
I just had a question, and it's something that I was surprised. I was doing some testing with children. I'm making a maths game. I'm actually doing it as part of, I've returned to college myself as a very mature student. I'm doing a postgraduate thing, but I'm making games, and basically we're making something I'm interested in doing afterwards, as well as educational games. We're making a maths game, and it's for 7 to 10-year-olds. And so I went out to test the maths. We had questions around the maths in the game and the actual, learning design in the game. So I took out, I didn't have a prototype of the game, so I took out a test with, and I tested first, second and third class last Monday. And it was girls and boys. And I'd asked the teacher to have, groups from children that find maths difficult to those that are, very good at maths. So I had a mixture of both in girls and boys. And they had to mark, you see, what we have as equations, and there's a question mark is left out in different places in the equation. So I had to work out, was there different difficulties depending on where it was. And they also have other things to do, because in the game it's a type of running type game, and then they're landing on numbers. So they have, they had to pick out, they had 10 coloured crayons, and then the questions were colour coded, so they had to find the question mark along. But the point was that in the 7-year-olds, the girls, like when it got to the more difficult maths numbers, they were only getting 10% right, and the boys were getting like 78%, like when I did all the results and I worked out the tables, the results. And then when we got up to the age, though, from 9 to 10, slowly the girls got progressively better. And then by the age of 9 to 10, the girls had actually surpassed the boys in the maths. So I'm wondering, is there something, is that just happened to be within those groupings of children, or is that something that, you know, because I was very surprised at the big variance at that age, and then, you know, the fact that the girls by the age of 10 had surpassed them in the...
Well,
in the
I'm
maths.
not sure what your sample size was, but I'm not sure either. It could be a gender issue. Terry, would you like to reference that?
I don't have...
Was just a fluke, or is there anything in particular? Because I'm wondering, should I take that into consideration for the game, or...
I'm not familiar with anything, but...
No, I haven't seen any
You haven't
gender,
heard, yeah,
any
okay.
gender issues myself.
You haven't seen that there's anything particular with girls between the age of 7 that they... No, okay.
No, sorry. But I would sincerely doubt at that age that it would. I don't think it's a cognitive issue. I don't think it would be a gender imbalance. I'm not sure what it is.
I was very surprised. I wasn't expecting it, and then it's something I noticed, and I just wondered why that was. It just happened to be there in the...
I'm not sure. Terry, can I ask you about how important Plus Magazine, Rachel, about Plus Magazine and why it's important to have it as a resource there?
So, I'm not from a teaching background at all, and I have ultimate respect for teachers because I do sometimes run workshops and work with classes of students, and the amount of energy and sheer kind of intellectual rigor you have to keep those kids engaged is amazing. So my background is I used to work in maths and industry, and now I usually write about maths. And it's a magazine for the general public, and we write about anything. We write about new maths research, we write about maths behind news, we write about maths in current events or in arts or in politics. So we really will write about anything. And I think it's kind of, what I said before, what we're trying to do is reveal, very similar to Terry's project, trying to reveal that there is maths everywhere. And I was talking to Terry before the event tonight and saying, I was telling friends about work in the pub, and they said, what can you possibly write about? It must be a really boring magazine. There must be nothing there to write about. And I essentially said, you give me a topic, you pick any topic, and I will find you a mathematical angle that I could write about that topic. Because that's the thing, and that's one of the things we try and do on Plus, is to take maths out of that old-fashioned, it's just tables, it's just numbers, it's just tools, and show how it's used, and how it's used in other areas of science, and really try and show it in as many different sort of guises as possible. And the other thing that we try and do is, one of the main issues I sort of have when I talk to people who aren't mathematicians or aren't mathematically curious, is that they think maths is this solid stone edifice that's done, that's accomplished, that's never changing. And what I think we try and do a lot is we try and present maths as a human endeavour, that's something that's an accumulation of centuries of individual people's thinking and knowledge and creativity. And also try to show that, there's cutting-edge mathematics. We're still getting there. We've still got, more questions to answer than we did before. So that's the kind of thing I think that we sort of focus on. And the way it's used is both by adult public, but also quite often when we work with school groups and when teachers interact with us, it's often used as sort of motivational material. So say if they're teaching derivatives or some probability or some kind of, early mathematical modelling. It's a way of kind of saying, this is why you should care about this. This is where this could take you. This is why it's an important thing to learn.
And do you think it's important then that as maths teachers and as the public that we should engage in mathematical research that's current?
I don't think maths teachers should be expected to be up with all the latest maths research, but what I would hope is that all maths teachers are really interested in what's going on in mathematics. But it's funny, I think mathematicians have a certain responsibility that they have to own up to. There used to be, and there still is in some universities, still this tradition of trying to put up a language barrier, of trying to make mathematics seem difficult, trying to make it as hard for people to get over into the mathematical world as possible. So I think there is a certain level of responsibility that some mathematicians have to take, and I think that's genuinely changing. And I think public engagement is one of the reasons that is changing. Mathematicians, as with all publicly funded researchers, realise is they have an obligation now to engage with the public. And so I think that's gradually starting to change, and it's now acceptable to be a research mathematician who is also engaged in talking to the public. But I think there is a certain amount of, there's now a little bit more free flow of information, and there's now people working in current maths research who are really interested in talking to the public. And so maybe that will make it easier for all of us, including maths teachers, to really, I certainly couldn't tell you all the details of latest maths research, but if you're lucky enough to have the right people to talk to or the right people to read, then at least you get a sense of what people are working on. You get a sense of what the new exciting areas are, and and get a sense that it's people accomplishing this. This is people's inspiration and passion, and some of the most over-the-top, passionate, verging on religious kind of expositions of things I've ever heard have been from mathematicians talking about various aspects of their research. It's an incredibly passionate and creative subject, and I think that's something that a lot of people don't really imagine. So
I think science communication is really moving forward as well. I'll take your question in a second, but I think your point about third level institutes dissolving the wall of the ivory tower, that's an important move. But because I think as scientists and mathematicians speak more about their research and engage more, I think that kind of breaks that little barrier and creates another link in that chain of more people becoming engaged.
And it makes it easier for people to become engaged as well. So.
Can we have your question, please?
Just 2 points. One is to applaud the work the PLUS magazine do, because I read it for a few years, several years ago, and it really got me hooked in maths, particularly.
Oh, it's lovely to hear.
Particularly the careers section. That was really what tipped it for me, because of course you can read all you want about technical details on Wikipedia or whatever you can read till you're blue in the face. But the key thing was the discussion about careers and the great variety of uses people have for maths in their professional lives, from fashion designers to movie set designers, to all sorts of people who started from a maths background. One thing, like you're trying to bring maths to more, to students in a more direct way. One thing I always thought was great was you had a discussion about computer-generated graphics that are used, like say in films everywhere now and for computer games and whatever. Yeah. But the fact that it's largely based on linear algebra. Yeah. And I was giving grinds to some first-year science students recently, and obviously linear algebra isn't the most exciting thing at first. But when I was discussing like rotations and transformations in space, and they're like, okay, that's fair enough, you can stretch a square or rotate a triangle, whatever. But when I explained to them like that is actually the basis of all computer-generated graphics, like they kind of understood it immediately, because of course you're dealing with shapes and you're trying to change them to change what you see. And they realized that maths is not something, people do for no good reason. It's actually behind most of modern technology. So discussing things like that in the classroom would be a major thing, and it's not that hard to do. I mean, like, you don't have to delve too deep into the subject. You can just deal with simple examples, and then they can obviously see that it makes sense. And
it's not hard to do, but I think teachers find it difficult if they're not being, if they're not shared with those resources and that information. So I think making that direct connection between industry and third level is really important if it's to follow on to second level and first level students.
Oh, I agree entirely, but that's the matter of teachers' training then. Like the mathematicians teaching teachers, do they emphasize these matters enough? That's one big point I would raise, like, because most mathematicians would think that trivial, for example. Like really professional mathematicians would think, oh, well, who cares about that? That's no big deal. But that's what matters to the man on the street. And another thing, trying to discuss pure maths research in schools as well can be done. Okay, you can't discuss, say, lengthy proofs because, no one cares. And I mean, a lot of it, no students care at the age of 15 or 16. I mean, I might care, but most people wouldn't care. But the key thing is you can discuss the theorems and the results. Like say Fermat's last theorem, like you're not going to read 300-page proof, right? But you can discuss the theorem very easily because it's very simple. Most of number theory, a lot of the famous theorems are very easy to state and explain, and they can see, oh, well, that might be vaguely interesting. Or another good one would be the Riemann zeta function, which is still an outstanding problem in maths, and no one has solved yet, and you may want to inspire people to solve it. It's not a complicated thing to state. You show the series, you find the zeros, and they're like, oh, well, that doesn't seem crazy to figure out, and it could explain like the prime numbers and like something which makes no sense to students.
But
in
can
their
I
age.
ask you the question then, is that not the mathematician's responsibility to be able to communicate that with people who aren't literate in that type of mathematics?
Oh, I agree. But
You know, people like Marcus du Sautoy have done wonderful things for mathematics. His books are brilliant because they're telling a really good story. But that should be, I think, brought to the masses.
I mean, to be fair, so I was a bit mean to mathematicians, perhaps. To be fair, not everyone has the talent for telling a story. So, but what we have to expect of academics and researchers now is they have to be, if they aren't, I mean, it's the most exciting public, accessible, popular maths articles I've read are written by researchers, because there's nothing like tapping that excitement of someone's own research. But not everyone can write like that. Not everyone can tell that story. So instead what they need to be is they need to be open to talking to a middle person like me, who'll come and ask them loads of probably incredibly ignorant questions, which can be quite frustrating if you're working at a really sophisticated level and then translating it into exactly what you're saying, something that someone can connect with. Because that's the thing, is I completely agree, you have to be able to connect these. There's no point telling someone about the Riemann zeta function unless you can get them to understand, the really fantastic, how that plays into, it's kind of like harmonics, it's kind of like the thing that tells us where the prime numbers are, and then you can explain why prime numbers are important. But yeah, I think you need to be able to tell a story. And so I think that it's about us as a culture realising that we need to tell those stories, and we need to sort of be sharing them.
Sorry, you go on.
Sorry, just a quick question on that. Like, is there a move within education circles to do that? Because all the examples of such things that I've seen are individual efforts, like say Darragh O'Brien's show on the BBC and and like Marcus du Sautoy's shows on the history of maths.
But
They're
if
all
this is
isolated.
about the engagement of the public, why is it the responsibility of the education community to take control of that?
Oh, I'm not saying it's necessarily their sole responsibility, but is there a move to bring dialogue on this into the public sphere at all, or is it entirely
from
isolated?
the perspective of working on I've worked on quite a few different public engagement projects. They are often, little islands. But the thing so I've been working in it mostly in the last sort of 10 years, and even in that space of time, in the last few years, who would have thought there'd be a maths game show, and there'd be, a US TV show with maths as kind of the driving how you solve a crime thing. Like, it really, to me, it sort of does feel like maths is becoming cool. Maths is now, so we got approached by someone, a TV production company, who's putting together a proposal for a Channel 4 series about maths, and they had crazy ideas of what they wanted to do. So I think I don't think there's a coordinated effort at all. And my personal experience of trying to coordinate the efforts of either public engagement people or academics is quite tricky. But I think as a general kind of enthusiasm amongst the whole community, I think it is growing. And I think it's what the reason it's growing is because it's been proved that there's a real appetite for good maths information, like maths as something that's entertaining to engage with. And I think people are realising that, and so that's the impetus behind a lot of these things.
And that's what a place like the Science Gallery, if I
Yeah,
can say,
absolutely.
it brings together the scientists and the academics and the artists and the creators, and then has that dialogue as well. Now, we've done a lot in the engaging the public, and I see there's a question there, but I would like to move the conversation to, assessment of mathematics seemed to get a reaction from the crowd there when I mentioned it, and professional development of teachers, because that's my own research area, but we'll take your question first, Shane. We just hold on for the mic, sorry.
Thanks. I wonder what societies have mastered this, and why don't we just copy them?
Well, I think
Terry? Or Rachel, sorry.
No, go ahead.
because when I was doing the project with Marcus du Sautoy, his big thing he always says is when he went to India, and also to some extent in China, the idea that someone would say, oh, I'm no good at maths, would just be like the most shaming thing to say, because I think particularly in India, it's quite an intricate part of the culture. It's quite, so I thought that was quite interesting. I mean, I don't know what they've done exactly that makes it that way, but it's interesting. It's a game. Maths is treated as a game for Indian school children, Indian young, and it's very involved in their music as well. So.
I think it's a good point, but I think it's a really massive culture change that in Ireland it's so okay to say, oh, I was terrible at maths. you know, every second person that you meet.
You'd never say
is
I'm
to
terrible
it.
at reading.
No.
It so annoys me. It's terrible.
No, well, but we've got Tyndall, we've got...
And I loved science, and I didn't see why it had to be one or either. But everybody seemed to think that if you're creative or artistic, or you were good at creative writing or literature, you shouldn't be good at maths. Like as if you had to have one or either. You couldn't possibly like both. You know what I mean? And that's the sort of, you know, that's the contradiction. I think you can like.
Oh, absolutely. I mean, that's totally valid. We are a hugely literate country, and we've got all of our literature, but we also have people like Boole and Walton and Tyndall and Hamilton. We've got this wonderful wealth of mathematics and science that we really need to be really explicitly proud of it, and I think to move it on a little bit more. So we've got 2 comments here and one at the back as well. We'll take those first. Oh, sorry, here.
I wanted to go back, and I think this probably links in with your next point. Probably links in with the point of professional development.
Great.
If you go back to your original picture of the sort of Victorian classroom, that originated, as far as I'm aware, from the Industrial Revolution and mass production. And it's a really, really effective model.
Yes.
And most of the people who are maths teachers and in maths research and things have come through that model very successfully. So if we're talking about changing that to a socio-cultural approach, I think the idea of training teachers in how to work in groups and how to work collaboratively, and training students who are also coming through a very much behaviourist approach to teaching and learning, that the actual training of group work has to be an important aspect in what we're doing.
Definitely. Can I take you up on a point, though? You said that that model was a very effective model. What do you define as effective in that?
That our society has continued to function successfully to date.
What's successful about that learning of mathematics?
Okay, good questions, and I would probably agree with you.
We assess maths in terms of procedures, and I don't think that's successful. I don't want to, you know, have a personal argument about it, but I think that that's where we really need to shift our philosophy. If we say that that model worked, yes, in terms of I could get an A1 if I learned all of my procedures and not understand them.
My point is that it has worked in terms of generating a culture of teachers who are propagating that model.
Yes.
So if we want to change the model, we need to train our teachers such that they can change that model, because these are people who have succeeded in the existing model, which is training them in procedural, in a procedural approach. It's not that I personally agree with that
You know,
approach.
you're completely right, and that's the culture that needs to change for teachers. And yes, as an institution that we have our professional development and education for teachers, that's our responsibility to introduce that philosophy to our teachers and to the experienced teachers at the moment. They need to be introduced to that philosophy and then be given the skills to operate like that. Yes, I don't think they should be thrown into it.
And the students as well, they need to be trained
Well,
in
may I follow that up and just say that my own research that I don't have anything here on, my own research is on a model of professional development that originated in Japan, and it's based on a community of practice of teachers all working in the same school on a process called lesson study. And it just happens there. It's happened for the last century in Japan, and this is why they are very successful at mathematics, at problem solving, because all of the teachers come together once a week, once a fortnight, once a month, depending on what school they're in, and they all sit down and just plan one lesson. Now, it could take 6 months to plan this one lesson because they only do it every time that they meet. And it's not about making the best lesson plan, but what it's about is those teachers having a conversation about all of the content knowledge that's in that, about all of the pedagogy that's in that, how they should teach it. And then one teacher goes and teaches the lesson and everybody else observes them in the group. So there could be 10 teachers in that group planning the lesson together. So one teacher teaches it, 9 others watch, but they're looking at how the students are engaging. And if that lesson doesn't go well, it's not the teacher who taught it, it's not their fault. It's everybody's fault because they all planned it together. And then they'll come back and reflect on that and say what went well, what didn't go well. And I had 2 schools who participated in that study this year, and they did that for a number of cycles throughout the academic year. And what we found out is that from participating in this lesson study, from this model of professional development, the teachers all learned more maths because they were sharing with each other. They all learned more teaching approaches because they were able to try out new things because they were in a safe environment. They all started to think about how students are really thinking in their classes. They all had more confidence saying, do you know what, I don't know how to do this, but I think my colleague will, and so I'll be able to ask them now, because they had that safe environment that was trusting within that. It was more collegial, more collaborative, and overall had just a model where the maths was improving and the teaching of the maths was improving, and they tried teaching in groups because they could do it with the support of their colleagues. So I think definitely we do need that training, let's say, to give our teachers that skills, but I think that we need professional development that's based in school for that as well.
Can I just come in there as well?
Terry, please.
And I think we can't lose sight that the world that we're going to be living in terms of our classroom in 10 years' time is going to be very, very different to the world that we have now. And that we have students coming through that are using technology, right? We have to be able to adapt. We need now to be planning for what we're actually going to be doing, because yes, group work and everything is important, but we can't. I mean, technology is becoming so invasive and offers so much potential. And it's like if we don't sort of plan now, we'll be waiting, and we'll say, oh, we now need professional development because now we're back where we have to introduce the technology. But we have an opportunity now to plan and say, well, how, as part of this whole continuous professional development, how are we going to, what view do we have? How can we start integrating this technology? How can it be used effectively? And over a longer period of time to start building confidence in our tutors, right? And in our teachers that aren't necessarily digital natives, right? And I think that's very important, not just to leave it as one.
Thanks, Terry. I'd like to follow that up, but I don't actually have much experience in e-learning, apart from GeoGebra myself. Can I take your comment, Jess?
Yes. I think I agree with everything that you've said. It all sounds wonderful. My wife's a teacher, and she would totally agree. She's German. She trained in a different country, and is rather critical of the Irish training thing, but she's a secondary school teacher. I'm rather involved in my young kids, 8 and 5, primary school education. And we haven't mentioned it yet, but I think there's also a problem of patronage in this country. My kids go to the local state-funded school, which happens to be a Roman Catholic school. And I'm wondering what portion of time they're spending learning mathematics versus the amount of time they're spending learning religion.
I can answer that because I just read the report today.
And Irish. So if we're talking about preparing our kids for the digital age, okay, and being competitive with kids who are coming from all over the world, who are competing with our graduates for jobs, okay, are we really preparing them well by making them learn that portion of spending that portion of their day learning religion, and I would say also Irish, but that's just me.
I might not agree with you on the Irish. From the Tims and Pearls report today, fourth classes, that's what they have, spend 14% of their time teaching maths, 4% of their time teaching science, and 10% teaching religion. So I do think that it's a relevant question. Would anyone else from the audience like to address that issue, though, before we move on? Yeah?
I'm just going back to my observation on myself as a child. You're saying there that the mathematicians should engage with the public. Well, I think it's time the public engage with the mathematicians.
Okay, good point, good point.
But as a child, I felt very alienated from other friends. And I was very quick at maths, but I found that I started leaning towards the humanities in my teenage years because I had spent so much time, I was so engaged in maths that I was missing out on the literal part of my education. And friends didn't want to know. They moved away because the class was boring. So going back to what this man said about his children, maybe there's an element of, I don't know if you call it bullying, or children just move away from mathematicians.
I'm not sure. Do you have any suggestions of how we could improve that then? Because that's a worrying observation.
I think the public should start engaging with the mathematicians and realising that we all have different talents in different areas. And if the teaching process could be, like, numbers jump at me in a fun way and always have, but for other children it could be letters jump at them, like the Letterland way of teaching. And why could we not just say, well, look, you look at this way in a fun way and I look at that in reading in a fun way. But as I said, I think mathematicians are put into a world of their own. And you're talking about philosophy. If you're good at maths, you'll be good at logic. And when you go into philosophy and you go into the field of logic, you're totally alienated, because that's another experience that I had in my mature years. Totally alienated, because the information comes to you very quickly, and you pick it up quicker than other people, so you logicalize information very quickly. And that can be the cause of you being alienated.
I wonder,
so are we are mathematicians a group on their own as meant to be?
I think there's, so I've worked in maths departments now for quite a long time. And although I used to joke that, maths departments were the places where people who couldn't possibly be employed anywhere else used to go, that was the running joke. But actually, the variety of people, I think the same as in any subject, the variety of people in a maths department is the same as the variety of people anywhere. And there's definitely people where, like a colleague who would probably be somewhere on the autistic spectrum, loves it and engages with it, so probably would be one of those people who would be quite socially isolated if they weren't in an environment where they had people they could engage with in a language that they like to speak. But then equally, you've got people who, we've got a group of sort of young researchers who are regularly going off to music festivals, giving talks about maths and theoretical physics in a field to people who have been doing goodness knows what. So I think there's as much variety. But picking up on what you're saying, I think one of the reasons people alienate if I say I do mathematics as my job, and they sort of go, whoa, I don't want to talk about that. I think it's just that thing that mathematics isn't seen as something that people do and as something that's fun. And so one of the projects I worked on, we developed these mathematical walking tours, and the reason that we did that was because Marcus was giving some talks at a school, and the teacher said, look, every other subject takes their kids out on field trips, and I've got nowhere. Where am I going to take my kids on a maths field trip? And so that's one of the reasons that he did this, was to kind of generate ideas for people of what they could...
we actually have something similar to it by Ingenious Ireland. There are walking tours around Dublin that are based on maths.
Yeah.
And just with your point as well, I just remembered that there's a brilliant lecturer, somebody else might be able to remind me of his name, from UCD, who writes for the Irish Times about what mathematicians do. Thank you, Peter Lynch. I knew it was Peter Lynch. And that's a wonderful way of communicating with the public. So it's a double communication that, yes, the public need to engage at maths, but and the maths community, educators, etc., need to engage with the public. But it is happening, and I think the zeitgeist is there now. I think you're both saying that it's time for it now. Hello, Ted. Is it? Yeah. Oh, Kieran, sorry. And I'll take the question at the back there as well. Sorry. Can I take your question, Kieran?
Just as someone who's involved in collaborative learning, just going back to the classroom, why not concentrate on cross-curricular? Why not have mathematics in every single subject? It's something where I am in Bridge 21 that we try to bring in, that's not just one single component, it's part of everything in life. And I would do the opposite and not put mathematics out in a limb, but have it as a core part of every subject plan that's in the classroom.
Before, if Terry or Rachel might like to address that, I think that the numeracy document will hopefully be guiding people towards that, and maths teachers need to push that boundary a little bit. There is collaboration, a lot of collaboration between the geography teachers and the home ec teachers in maths, and even in art that I've come across. But I think you're definitely right. There's a lot more scope for it.
I just come in that because I've been doing some work with some schools, because the strategy for literacy and numeracy for young people is encouraging the integration of numeracy across the curriculum. And part of the Developing Maths Eyes project and the way that we're using that within schools is not with the maths teachers, but it's with all the people that don't teach mathematics, to open their eyes to the opportunities there might be for introducing mathematics in their classroom. And they all start with saying, there's nothing here. I'm a language teacher, there is nothing here. But a lot of my work with the secondary school teachers has actually been to try and work with the non-maths teachers and say, yes, there is. And that actually does have a big impact, because in a way it breaks down a wee boundary between the mathematics and all the other subjects. And they have the confidence, once they realize, they're saying, look, I'm thinking about doing this in my class, but they can actually go to the maths teachers to ensure that, to build their confidence until they're doing it. And that seems to be quite successful. So this concept of opening your maths eyes so you actually see the mathematics opportunities that are there.
And I think that's a really nice project for people to just go around and take photographs of the maths that they see around them every day. It might even be a nice social media project to continue on from Math's eyes.
And don't forget Math's ears, because if you listen to what we have to interpret all the time. This morning, if you were saying this morning, we had our percentages for our new abortion legislation.
Okay.
And then we had that wonderful one where Kerry, I think, was 14th on the crime score this morning, because it scored very low in everything except public order offences. So it actually made it that it was one of the high crime spots. But just to even explore that in the classroom, well, how did that actually happen? Right? And that was just on the radio on the way in this morning. So it's about opening your eyes and your ears. So you're actually listening to what's actually happening.
We're going to run out of time. Sorry, so can I take this one question here? Yeah.
Hi, I just want to go back to the whole thing about, there's a bit of an emphasis on this kind of rock star mathematician thing recently, and I think we have to be just a little bit careful with that. I think we also need to have the more grassroots approach, the bottom-up approach, and parents are the primary educators, so it's important that parents encourage their children to get involved in maths. But I think it's a very exciting time for that, because with the digital age, parents have become very much empowered that they can actually go back and look at the maths that they weren't able to understand in school first time round, and look at a video on Khan Academy or YouTube or other systems, and actually go, oh, so that's actually what a quadratic equation is, and for the first time in their life actually realize that's what it's about, and it's not even that hard. And it's very, very powerful, and you can have parents then who are teaching their kids instead of sending them out for grinds, and I've had this experience myself where people have used our system and they've just been so delighted, and it's just brought peace of mind into their house, because finally the kids can do the maths, and the parents are so happy because they're able to do it in an inexpensive way. And I think that grassroots stuff is so important, that it's not all about the glamorous theorems and the rock star mathematicians. The thrill that people get out of solving a simple linear equation is actually, I think, even more important to the general public.
I just did some interviews with people for a project I'm working on, where both mathematicians and non-mathematicians saying, was there ever an experience or an idea or a kind of goal that made you interested in maths? And what's really interesting is it's both mathematicians and non-mathematicians. It's something experiential. It's something about doing something. So quite often for people who are hooked on maths, it's the experience of solving a linear equation or solving a trig identity, and that kind of satisfying click you get when it comes together. But for people who tell me and were very hard to convince to interview because they say they weren't mathematicians, equally it was something about that feeling of getting control of something, or they would often talk about games they like to play or puzzles they'd like to do. But I think but also it's. I don't know if it was always with parents, but I think it's that engaging with something, and it's that, and particularly the people who are non-mathematicians, it was things that didn't matter if they were good or bad at them, because that's the thing I have about maths, and it'd be interesting to hear, your points of view given your understanding of the education now. But, I think sometimes the way maths is assessed is that really early on, my son's 7, and he and his friends already have this idea in their head of who's good and who's bad at maths. And I think at 7, I almost wish there was they didn't have to feel good or bad at maths. They could just know it was something that they could do.
So sorry, yeah. Let me take your point.
I'm a primary school teacher, and I'm frustrated by the lack of understanding, we'll say, of the teaching of maths, of what's actually happening. So this year, what I did was a small research project within the school, and I took 3 different age groups, 4 5-year-olds, 8 9-year-olds, and 11 12-year-olds, applied the same strand of the mathematics of the curriculum and gave them age-appropriate tasks. And with a non-biased way, I've just sat down and literally just looked at what the children were doing. And the most striking and the most obvious thing of all was they have to know what you're asking them to do before they can engage. That was, and it was, sort of kind of like egg on my face. Like I say, this was the thing that they really had to know what you were actually asking them to do. The second thing was very striking, language. Children who didn't have the correct or were not articulate weren't able to, and that applied to each, the three groups, that if they didn't have the ability to talk their way through the problem. Like for instance, we'll say one of the 5-year-olds was looking at a problem and he knew it wasn't correct. And he kept saying, it doesn't rhyme. Now what he was trying to say, it doesn't make sense, but somebody else said it to him. In the collaborative learning, like, the problem with the collaborative learning, like, where you have a group, where what you were talking about.
Can I just go back to that point that you just said, that he didn't know how to explain it? That's what I mean about the teaching of maths has to involve talking about it, because if I'm able to explain it to myself, if I can bring my thought process and verbalize it, that means that I know the maths. And literacy is a huge problem now, especially with our new curriculum, but it's the maths teacher's responsibility to be aware that their students also need to be literate in the mathematics that they're learning, not just the questions, but how can they explain them.
It's being empowered by language. Some children, they're not able to articulate their ideas. Some would be at a different level. And then when you come to something like collaborative learning, where you have a group, you might have a very vocal child, which happened in the 3 different groups, who was completely on the wrong end of whatever task we were doing. And that child then took over. And it meant then that the child who actually understood it sat back and didn't engage with the task, or let somebody else take over. So what I'm saying is, like my conclusion from there was that you have to be very careful when you're choosing or when you're grouping the children.
Yes, also, but did those groups work together again and again and again?
Yes, what I did was I took 2 sessions. And in the first session, I would we'll say, state the learning objectives, or tell the children what I wanted them to do. Then I went back and just looked at what I had written down and looked at what I had observed, and then went back again and maybe sort of gave them a little bit more of a difficult task. And it was just purely non-biased. I just wanted to see what is actually going on. Why are these children not picking up on so the language was a huge thing. They didn't understand. The other thing that was very, very helpful were concrete materials. The children, and this even with the 11, 12-year-olds, I thought, like, it would be a bit naff, like, them sort of, because I was doing cube numbers with them, and they could not see the pattern, like, of that 3 cubed is 27. They kept saying 9, and then they start playing around with the cubes. And then the more able children actually went and took the concrete materials and started creating their own patterns.
That's, being active in the maths is all part of the learning. And I think, it's great to see that it's working. But I think what you were saying about the vocal student, you see, as the students get used to working in groups, they realise themselves the roles that they have to take on, and they actually don't let people govern over if they're doing it consistently over a long period of time. And I hope you don't mind, but this lady behind, I'm so sorry, I came over you earlier. Did you have a question you don't want to?
I had come about 7 at this point. So,
and I think we're going to have to finish up soon. So if somebody's looking after the time, if we take Sean, how many more questions will we? 2 more questions after that. So. Yeah.
I was just going to say, I've done some voluntary work now and again in schools, and when I go in and they ask what you do, I say, well, I'm very lucky. I get paid to do maths all day. To senior infants and first class. I work as a pensions actuary, so I'm really delighted to hear you've looked at your pension and realised the situation you're in now.
Don't worry, I started paying it as soon as I did that calculation.
But when we're talking about the collaborative learning here, I work in a consultancy, and that's how we teach.
Exactly.
That's how we learn. That's what happens when you get out of school, because we need to be effective in how we learn. We need to be up to speed, on the minute. We need to know exactly what's going on as fast as we can. You learn the go-to people on who knows the most about this part, that part, to go with your questions. It's always in a kind of a group learning sort of situation, because that's what works best. And that's just what's evolved, because that's when we have a group of people, that's what we found was how people just instinctively move towards learning. So I'm really glad to see the classrooms could move towards that. But I think, as this lady in front of me here has pointed out, I think it comes down to professional development.
Yeah.
It's a skill to learn how to do that in a classroom. You know, in my situation, it's fine because I've got a load of people motivated by a paycheck, so it'll happen. Children, the paycheck doesn't work as well, probably. But, so I'm really pleased to see where things are going, especially also as a parent with young kids. I haven't yet had my daughter say anything bad about maths. I've had her tell me that only girls are nurses and only boys are doctors. And then I asked her, well, what about your aunt? She's a doctor. Has she had a sex change? You know, you get that stuff coming through. And the one other comment on the literacy is just reminded me of, it's come up before about how we actually, the numbering, like 1, 2, 3, 4, and the teens and the 20s, actually the way we do numbers in English is kind of gobbledygook all over the place compared to a lot of other languages where it's much more orderly. And does that actually kind of affect younger children's learning of numbers and possibly influence on them in that there's a whole illogical sequence to it? It doesn't just go 1 to 10, then, you know, it doesn't even do it quite in Irish, but I think some of the Asian languages, then it would be just 10 plus 1, 10 plus 2, 10 plus 3, 20 plus 2, 1, 20, 2 tens plus 1. So, you know, something more like that, but is that
I know, I think that's a good point, that they need to be so familiar with what the number symbol is, and it's the symbols within that. And interesting enough, the Chinese actually group their numbers into male and female, and the stronger males are the primes, and the weaker females are like the really round ones, like 20 or 22. But bizarrely, like that's how I did that as a game in my head. Like the odd numbers were male and the female the female numbers were even. And I think even creating that game and those visual images around numbers are really important. But thank you for your comments, because I think that's nice to hear from industry. Now we've got a comment up here as well, a question, yes.
Hi, I'll try to be really quick. Just as a student, and this is kind of bringing it back to the assessment as well, I'm doing my junior cert at the moment, and I've just done my maths exam.
Oh, well done.
And I think my year is the first year to do the new project maths as the curriculum from first year upwards. Is that with the new curriculum, what I've been taught is that it's a lot more about understanding what's been asked of you yourself without actually being told. And I think the problem is with that is that the curriculum has changed, but at least in my experience, the teaching methods haven't really changed. Okay. So you're still being taught that, you know, learn this and this and this. But if you ask, why am I doing it? I know I need to understand this to be able to learn it and be able to take that out of context and do that in the exam if they ask me something and I have to figure out what I need to know, what I need to be able to do, whether I'm using Pythagoras or whatever I'm doing. Is that, you know, if you ask, why am I doing this, or how will I take this out of context, you're being told kind of, you know, come back to me in 5th year when we explain all this. And I'm kind of going, well, I need to know this now, because in order for me to do that and do everything you ask of me later, I need to understand why I'm doing it. And I think that the problem is that the new curriculum scares teachers, because they don't know what's being asked of them either, you know?
Well, thank you so much, and I hope your exams are going really well, and you've articulated that incredibly well. I think a lot of teachers are actually afraid of trying something new, which is understandable if they've been teaching for a long period of time, or if they don't have that knowledge of maths themselves and they don't feel confident enough to be able to teach someone like you who's very bright. So I think that that's what they need. It's professional development that's really sustainable, that's structured, and that's supported. That's not going to help you right now, but I think that you can, I'm sure, like, you know, you're resourceful, and you could probably go and find someone else to ask, or have a look on the internet, or even like what a lot of students do is go and find different textbooks that challenge you in different ways. But thank you so much, because that's really good insight, and I hope the exams go well. I'm sure they will. Let's take our last comment, and then we're going to have to go, and I'm going to let the microphone holder decide, because we've got two either side here. Sorry, Paul. We'll fit you in afterwards. Okay.
Hi, just in kind of response to the whole assessment side of mathematics, I'm doing my leaving cert at the moment also.
Oh, God.
And after taking maths paper 2 on was it Monday or Tuesday, I'd just like to say that you know, the project maths is fantastic in everything, the way it's like targeting more explorative ways of looking at maths and problem solving and everything, but it just annoys me so much when I had to go into a 3-hour exam and, you know, look at questions that, sure, if I was at home in my pajamas with a cup of tea, that, you know, I could have solved no bother, but it's just that you know, in the exam situation, the pressure and everything really affects how students do with maths, and I don't feel that it's like a really a fair reflection on mathematical ability at all. So I really think that has to be something that's looked at.
I think a lot of people would agree with you. I think it's unfortunate that our whole education system is streamlined into one state exam at the end. I think as junior cycle reform comes in and there's more continuous assessment, that will follow on with senior. Now, I think there is space for a state assessment at the end, but maybe that it's not 100%. I'm not an expert on it, but I think you make a very valid point, and I imagine that our whole system will be shifting slightly, but it will take a long time to get there. How did the exams go?
Fine, yeah.
Good, well done. Best of luck with the rest of them as well. And we'll take our last comment for today.
Just to thank the panel for a really interesting discussion. Something that everybody here hopefully will be interested in is that we have an annual Maths Week here in Ireland.
Okay, great.
It's an Irish week. It runs for 10 days, and this year it's from the 10th of October to the 22nd. It includes maths fairs, puzzles, maths on the street on October the 12th, and everybody's invited. And Maths Week Ireland is the website.
Thank you very much, Paul. So that's a good plug. So that was my little joke for today. Yeah, please do, Terry.
It's just that some of the, I don't know what posters were put up, but some of the Maths Eyes posters that are up outside the door, some of those were actually produced as part of Maths Week last year by schools, from primary schools under 7s to adult education centres. And what they were doing was showing how they had their Maths Eyes. So that's just some of the stuff that was produced.
And I think that's something that everyone can get involved in, Maths Eyes. Maybe we could start a hashtag, Maths Eyes, and just, you know, while you're watching bridge signs or height signs or octagonal spaces that are around you or roundabouts or whatever it is, like find the maths, the 10% off in the sales. I think we could probably spend hours talking about this, because this is a room full of people who are interested in education and in maths education. Hopefully this has been a useful discussion. I think it's possibly even too broad to have within the time that we've had here. But I would like you to share your appreciation for Terry and for Rachel for joining us today and for their angles on it. Thank you. You can find Maths Eyes and Plus Magazine online. Risk Lab is open for another couple of weeks, and please feel free to go in and enjoy the poker table. Try and learn your probabilities of the roulette table, the risks that you're taking in your everyday life and your insurance. And thank you very much for joining us at the Science Gallery today.